So let's go to our example, and of course, in this loop, in the loop, semicolons are used as delimiters between the three parts, between the initialization condition and increment decrement. And here I place my initialization of the loop controlling variable outside of the loop, before the loop. Why would I do this? For instance, if I wanted to say, if I wanted to add another output statement right here, and I would say count, print count is this after the loop. After the loop. Right, so let's comment out these little demonstrations, because they will generate syntax errors or whatever. We run it. Something's missing. Yeah. Oh, I forgot to add another output operator here to keep everything correct. Right. Run this, and this is what we get. Is output. So right now, this is the type of output that we generate. So you can see that, of course, everything is expected. Count is 0 after the loop, so we exited with 0. 0 is no longer greater than 0, and we exited the loop. We printed the statement, and then the program ended because we returned from our main function. Right? So this is our main function. So, but you see how the loop controlling variable count was used after the loop was complete, outside of the loop basically. When that's the case, you have to do this. However, if I say, oh, this is my initialization statement, and I want to place it where it belongs, right here, right? I could structure it like this. In this case, if you initialize variable, create the variable, part of the for loop initialization, let me try building this. Look what happens. It complains that the counter is undeclared identifier. Okay, and the answer to this situation is that if you want to keep the counter variable only for the duration of this loop, you can initialize it here, and its scope and visibility is limited to the loop. So therefore, I am not able to do this anymore. Okay, this counter disappears after the loop. It is created before the loop executes, and then it is destroyed right after the loop stops running, right after we exit the loop. So sometimes it's okay to keep these variables local to the loop, right? Available only to the loop, and that would be the situation here. In many cases, you may try to continue using this variable, and then you can just go back to the way it was written, so that the initialization statement was right before the loop. So few highlights here. Initialization statement, let me just make this visible once again, right? This initialization statement, which now I have, right? So this is my initialization statement right here. Simply creates the variable, assigns the value to it, and then we continue using it. Initialization statement is executed only once, right? So executed only once. Then the condition is checked, right? The condition is checked. And if condition is true, we enter the loop, right? Just to remember this order. First, initialization happens only once. We enter the loop only if condition is true. And then upon completion of the first iteration, we go to the increment or decrement statement. And after that, we go right back to the condition checking, right? So this statement is executed only if we have iteration completed, and upon completion of the iteration, we come back to the statement, right? So again, the order is do this only once, then check the condition over here, then if condition is true, execute this, and then execute the increment statement. And that completes the first iteration. And the next iteration begins with checking the condition again. So this is basically circling like this in this loop, right? This is the order of business. So we had our, so let's bring it back. Like I can keep my initialization empty and bring back my initialization outside of the loop so I can continue using my variable because I want to continue examining its content after exiting the loop. And how about this? What if I decided that I want to exit my loop before it's complete the way it is written right now? It's possible to combine it with an if statement and say, okay, if, for example, count equals 3, if I wanted to exit the loop at this stage, what I could do is simply say break. Okay, so the break statement, which is just a very simple statement, tells the compiler that if somehow we were able to get to execute the statement, we exit the loop, and so therefore this is something that will happen after the break, right? So break takes us immediately out of the loop. Immediately, we're done with the loop and we get out. So let's see how this works. What does it do? Okay, I build this and I run it. And this is the output that I get. So right now the output changed to this. So we started as normal, we just keep checking whether the counter is greater than 0, it's 5, then it's 4, then it's 3. So once it's 3, we hit this condition again, and the condition becomes true, so we execute the break statement, and the loop terminates, right? So the loop, so over here, loop immediately terminates. And the terminates meaning is that the terminate is just like the next statement that will execute is just the next statement that follows the loop, right? That's the termination of the loop. Okay, questions about this? Let me know at any time, because I'd like to demonstrate something else. Now, let me just get rid of this if statement and go back to the original. We run it. And this is the output that I get. Very good. We're back to this full output. But this time, what if I wanted to skip a specific value? For instance, I would like to skip printing 3. So what I want to get is 5, 4, 2, and 1. And do not print 3. Okay, of course I could use an if statement and say as long as count is not 3, right? Because 3 is some sort of magic value. I don't know the meaning of it. So only if count is not 3, then do this printing, right? So I modify it like this. So I wrap the entire output statement to print the non-zero values under this condition. Well, let's just check this. You see, I skip it. It prints everything except 3, which is expected, right? It's not that difficult to follow. That's what's happening. So now you can compile your looping constructs with your if statements and so forth, and that's what I did. But here's another example. It's possible to also, inside the loop, say if the count is 3, and say continue. So there is also a continue statement that allows you to actually, as soon as this statement is hit, recall how with the break statement I said the loop immediately terminates. We stop looping and continue with our program. Otherwise, continue, jump. So continue statement is, the meaning of it is jump back to increment, decrement, and condition. Right? So continue statement takes us out of the body of the loop, but doesn't stop the loop. Instead, it says what's next after the body of the loop. Well, it's increment and decrement. So this way, I expect that the behavior of this little thing is going to be similar to the example without continue. Just to give you example of the continue statement inside the loop. Executing it, you see that it's the same outcome. Right? So what it prints is exactly the same output.